Okay, so today we're talking about parallel lines being cut by transversals. We covered angle pair relationships, corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles. But when a transversal is cutting two parallel lines, something special happens with those angle pairs. So the first thing we're going to start with is the corresponding angles postulate. So if we have two parallel lines, and how do we signify that they're parallel? Yeah, the little arrow thing through it. Okay. And then they're cut by a transversal. We're going to start with the corresponding angles postulate. Now, the corresponding angles postulate says that if you have two parallel lines cut by a transversal, then the corresponding angles are congruent. Angle 1 would be congruent to angle 2. Now remember, since it's a postulate, we're not going to be proving it. But we are going to use it to prove some other angle pair relationships. And we're going to use what we know about corresponding angles to find measures of angles that we don't know. So the first diagram they give you in the first example has two parallel lines. How do we know they're parallel? The little arrow thing, that's definitely the technical term for it. And they're cut by a transversal. And the measure of one of the angles is given. We need to find the measure of all the other angles. Well, let's start with this. Which angle is corresponding to that 120 degree angle? 5 is the corresponding angle. So that means the measure of angle 5 is what? It's 120 degrees. Now, if I know that that labeled angle is 120 degrees and angle 5 is 120 degrees, what other two angles have to be 120 degrees? What's that? 4 and 8. Why? Yeah. Because they're vertical angles of 1 and 5, so they must also have the same measure. Because vertical angles are congruent. So far, so good? Alright, so we've picked out all of the ones that are 120. Can anybody tell me what all of the other angles would measure? See? Why? Okay, so 180 minus 120 gives us 60. How do we know that we can do 180 minus 120? Because they're straight lines, which makes the angles what kind of pair? A linear pair, and we know that linear pairs are supplementary. They add up to 180. So all of those angles are 60-degree angles. Make sense? So that only works if the two lines are parallel. If they're not parallel, then we can't connect all those angle pair relationships. We can still use the linear pair, we can still use the vertical angles, but we can't use corresponding angles. Now, once we have the corresponding angles postulate, we can use that to prove three other angle pair relationships. The first one is the alternate interior angles theorem, and that tells us that alternate interior angles, like these two, are congruent. Alternate interior angles are congruent. We'll actually prove that here in a few minutes. It's a pretty simple proof to walk through. Now, we also could prove that alternate exterior angles are congruent. So we have corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent. We had one more type of angle relationship. What was it? Consecutive interior angles. Consecutive interior angles. What do you think we could say about consecutive interior angles? That's right. What do we call that? Supplementary. They're not congruent, they are supplementary. Consecutive interior angles are supplementary. Everybody got those down? Again, what's the requirement for those three theorems to be true? The lines have to be parallel. If they're not parallel, all of those fall apart. So if we look at example 2, gives us another diagram. And it asks us to find a value of x. So we have to use what we just learned about the properties of lines, or the properties of angle pairs, to set up an equation to use to solve for x. Now, do we have an angle pair relationship for the 115 and the x plus 5? No. Do we have an angle pair relationship for the 4 and the x plus 5? What relationship do they have? Consecutive interior. What do we know about consecutive interior angles? They're supplementary. They add up to 180. Now, what about 4 and 115? Do we know anything about them? They're vertical angles, so what do we know, T? That 4 is 115 degrees. So we said that measure of angle 4 plus the x plus 5 has to equal 180. So we can replace that measure of angle 4 with 115 because we know it has to match the 115 degree angle because they are vertical angles. So that tells us that x plus 120 equals 180. So what does x equal? 60. Now we don't need to put the degrees there because that 60 would just go into this expression, which already has the degrees outside of it. Okay, x doesn't need that unit on it. So that's the only value for x that would make that statement be true, that would make those lines parallel. They're going to ask you the question in that kind of format in the homework. They're going to say, what value for x would make these parallel? Okay, so when you're approaching it that way, just assume that they're parallel, set up your equation from what you know, and then solve for x.
So vertical angles equal the same?
Vertical angles are the same measure. Yep, they're congruent. All right, so now we're going to prove the alternate interior angles theorem, and we're going to use the corresponding angles postulate. So let's just set this up real quick. Let's start with a pair of alternate interior angles. And I want to prove that those two are congruent. Now, as I said, I'm going to use the corresponding angles postulate. Okay. So I want to set up an angle that either corresponds to the 2 or to the 1. Doesn't really matter. Okay. I'm just going to put it down here. Okay. So angle 1 and angle 3 are corresponding, right? So if angle 1 and angle 3 are corresponding, what do we know? They're congruent. Okay? That's the corresponding angles postulate. Okay, I'm just kind of writing a bit of an outline here. All right, what do I know about angle 2 and angle 3? Why? Vertical. That's the vertical angles congruence theorem, right? And so what could I then use to state that 1 is congruent to 2? The transitive property of congruence. So we could set that up in a 2-column proof. We'd start with the fact that our hypothesis is given that our 2 lines are parallel. Okay? So if we're given a diagram, a tiny little version of it with 2 lines, I'm just going to do a quick little sketch. 1, 2, and 3. These are lines P and Q, and they're parallel. So our 2-column proof would kind of look like that. It'd start with P is parallel to Q. What's the reasoning? Given. Okay? And it has to be given because that's part of your theorem. Your theorem states if the lines are parallel. So you have to start with the hypothesis being true. Okay? Then, angle 1 is congruent to angle 3. We gave a reason for that, right? What was it? Corresponding angles. What? Postulate. And then we said that angle 3 was congruent to angle 2. That was the vertical angles, what? No, we proved it.
Vertical angles.
Congruence theorem. Okay. And then we said that this means that angle 1 is congruent to angle 2 by the transitive property of congruence. Why am I not using the transitive property of equality? Because I'm not. Because we're dealing with congruence, not with equality of measure. Make sense? So your proving alternate exterior angles would look very similar. Okay? If we had to run through a proof of alternate exterior angles, like these two, okay, we'd say, well, I know that if this is angle 3, I know that 1 is congruent to 3. Why?
The
corresponding. Okay, those are corresponding. And 3 is congruent to 2. Why?
Because of the vertical.
And so I'd use my transitive property again to get 1 and 2. Right? For the consecutive interior, okay, I want to prove that these 2 angles are supplementary. Right? I know that 1 and 3 are congruent, right? Okay, so that means that the measure of angle 1 equals the measure of angle 3 because they're congruent, right? And I know that the measure of angle 2 plus the measure of angle 3 equals what? Equals 180. Why?
Because they're vertical.
Nope. They're supplementary because they are a linear pair. And then I can use substitution to replace the measure of angle 3 with the measure of angle 1. Okay? All right, so last example. Nice picture of a rainbow. When sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 is 40 degrees. What is the measure of angle 1, and how do you know?
Aren't they alternate?
They're alternate what? Alternate interior angles. We know interior because they're inside the parallel lines. And so what does that make the measure of angle 1? 40 degrees. Everybody okay with that? Any questions? All right, you got homework.